Alright, now we're going to look at some more examples of determining if a limit exists or not by looking at the graph. Of course, we just finished talking about the three situations in which a limit doesn't exist, so that's what you would need to keep in mind with these problems. Alright, so the first example that I have graphed, it says, of course, the limit as x approaches 2 of f of x. So they don't have the actual function written here this time, but this is the graph of the actual function. This is f of x. Alright, so you want the limit as x approaches 2. So your x value is 2. Alright, so if you go to x equal 2, the thing is here, of course, you do have this point, which is part of your function. Anything that's on the graph is part of this function that is located here at -1. And then, of course, up here, you've got the open circle, which again would indicate that just that portion of the graph is not defined. But when you start looking at it, you know, from the left side and looking at it from the left side, like I've talked about, you actually can't look to the left and to the right of this point because it's just that one individual point. So when you're looking from the left and right of x equal 2, you'll have to pay attention to this portion of your graph. Okay, so right here's your x equal 2. Alright, so if you start looking from this right hand side, you know, as you come along that graph, as you get closer to where x is equal to 2, of course you're closing in on this open circle just like you've seen with the other examples, the y value there, even though it doesn't exist, that y value there is at y equal 3. Okay, then you've got to look at it from the left-hand side. So then if you look from the left-hand side, again, as you come in, you're approaching this same location, which again is at a y value of 3. So the limit as x approaches 2 for this particular function would be at 3. Again, it's the y value of 3. Now it says if it doesn't exist, then explain why. This one existed, so there is no explanation that you have to give here. Alright, next one. Okay, just like a while ago, we're going to look at it from the left and look at it from the right. So this time, for this particular function, I have the limit as x approaches -1. Okay, of course, right here is -1. Now, if you're going to look at it from the right-hand side, you're going to have to look at it on this portion, because this is the portion that would fall to the right of -1. Alright, so as you come along and you get closer to where the -1 is, of course, this time you're approaching in here, which is closed in, but you know, just like I told you before, it doesn't matter if it actually exists there or not when you're doing a limit. Okay, so you're approaching here, which has a y value of -2. But then if you're to look at the graph or the function that's to the left of -1, that would be this portion. Okay, so as you come in and you get closer to where your -1 is, you're approaching this open circle this time, which has a value of +2. So from the right, you're approaching -2. From the left, you're approaching +2. So that goes back to actually the very first example I gave you where a limit doesn't exist. Explain that the limit from the right and from the left have to be the same, and since they're not, then this limit does not exist. What you can do is just abbreviate it DNE, does not exist, instead of writing it out. Now, since my limit doesn't exist, I do have to explain why, and you can just let me write a little quick explanation here. You can just say f of x, meaning the function f of x, approaches different values from the left and right as x approaches negative 1. You can just use an arrow there to stand for approaches if you want to. But just, it doesn't require a paragraph, just, a basic little statement, of one of those three things. It has to be one of those three situations that you're going to explain. Okay? All right, third one. Okay, so this time I have the limit as x approaches negative 2 of f of x. Again, this is our function f of x. Now, negative 2, of course, that's located here. Okay, so if you're to approach negative 2 from the right-hand side, then that would have to be, this portion, okay? So, of course, as you're getting closer to the negative 2, what happens is your graph turns and goes up forever. So this is going to end up being that unbounded situation. Now, if you look at it from the left-hand side, as you approach negative 2, your graph turns and goes down forever. So here your y values increase without bound. Here your values decrease without bound because y keeps getting, smaller and smaller and smaller. And here your y value gets bigger and bigger and bigger. So again, this is a situation in which your limit does not exist. So on this one, you can't really say, be specific and say that it increases without bound or it decreases without bound. I mean, you can, but you'd have to write two separate statements because it decreases on the left and increases on the right. So again, just a quick little explanation as to why it doesn't exist. You could just say f of x just say is unbounded. From the left and right. You just don't have to be specific about increases or decreases here from the left and right as x approaches negative 2. So again, just a brief explanation as to why not. Okay, next. Alright, so what you're going to want to do here, of course, is sketch off this graph. And what we're going to do is kind of look at two parts here at a time. So we're actually going to do an A part through an F part, but all of it is going to be in reference to the graph that you're seeing here. So use the graph to decide whether the value exists. If it does, find it. If not, explain why. So this is, similar to what we were doing just a few minutes ago. Now, a while ago, the question was specifically about limit. Here is just a question about just the function in general. Okay, so first of all, it wants to know what is the function's value at negative 3. Now, this is just function notation, same thing that you have done many, many times in the past. If you remember, your value that's inside your parentheses is your x value, and what it's going to be equal to is the y value. So actually, when you're done, it's an ordered pair. It's just an ordered pair that's written in function notation, where this is your x and this is your y. So you're going to go to your function and locate x equal negative 3. So of course, right here is negative 3. And if you'll notice, at negative 3 is where you have a vertical asymptote. So of course, there's been various things that you've done in the past in other courses in which we've talked about vertical asymptotes. And a vertical asymptote means that your function is not defined. Your function does not exist in that location. So since negative 3 has the vertical asymptote, then the function does not exist. Okay, now saying the function does not exist is different from like a limit not existing. Okay, all right, B part is still in reference to what's happening at negative 3, because this time we're going to go back to a limit. So limit as x approaches negative 3. All right, so negative 3, again, if you look at it from the left and then or from the right and look at it from the left, I forgot my arrow here, but this portion does continue to go up forever. But from the right, as you get closer to x equal negative 3, your y values just continue to increase. It turns and goes up forever. Same thing happens on the left-hand side, so that would be that unbounded situation. So that means actually your limit does not exist either in this situation. Now, it says if it does not, then you need to explain why. So you could just, explanation like I gave you a while ago, just say your function f of x. This time you could be specific and say that it increases, and we'll say without bound, as x approaches negative 3. Okay? Now, just because this does not exist does not mean this does not exist, and vice versa. You can have one of these existing and the other one will have an answer. Okay? So, don't assume what one does, the other one does too. Alright, next one. Again, these two are related because they're both in reference to negative 1. So, first of all, what is the function's value at negative 1? Alright, here is the x equal negative 1. Now, when you go to locate your graph, of course, the open circle here means that this portion of the graph is not defined at negative 1. But you wouldn't say that your function does not exist because it does exist. It's just up here on this portion of it. That's where the circle is filled in. And the y value that you have there is a y value of positive 3. So f of negative 1 is equal to positive 3. Okay, now the limit as x approaches negative 1. Okay, so again, here's my negative 1. If I look at it from the right-hand side, of course the right-hand side's closing in on this part that the dot here, or the point where it's closed in, which has a y value of positive 3. But then if I look at the portion that's to the left side of negative 1, this part closes in on the open circle, which has a y value of positive 1. So the right side approaches positive 3, the left side approaches positive 1. And remember, for the limit to exist, it has to approach the same from both sides, and it doesn't. So this is a case in which your limit does not exist. So just say f of x approaches different values from left and right as x approaches negative 1. So again, that's just a quick explanation as to why it does not exist. Okay? And actually here I have a does not exist, and I forgot about giving an explanation here. And there's really not anything that you can say much other than just the fact that it's undefined. Okay, so you could just say function is undefined at x equal negative 3. And I'm really not so concerned with an explanation here as I am on these limits. Now, actually, when you do your homework and you're looking at answers in the back of the book to double check your work, they'll have an explanation on this one, but this just says the same thing that says. It's just undefined. It does not exist. Like I said, I'm more concerned with you being able to give me the explanation here with the limits. All right, last two little parts. E and F. Alright, so F of 3. Alright, so we're over here at positive 3 this time. Now again, this is just, is the function defined at 3? Well, the only part of the graph that lines up with x equal 3 is the open circle. Open circle means that it's not defined, so does not exist. And again, I'm not going to bother writing an explanation. Alright, limit as x approaches 3. So look from the left, look from the right. So again, here's x equal 3. Which is putting you right here at this open circle. Well, if you look at it from the right-hand side, again, you're approaching that open circle, which is located at 5. But then if you look at it from the left, you're also approaching the open circle, which is also located at 5. So approaching from the right, approaching from the left, they both close in on a y value of 5. So it's like this one doesn't exist, but this did. This doesn't exist, but this did. Here, then neither one existed. So again, you can have different combinations, and you can have answers for both of these. Okay, so just don't assume one answer you have for the other, you will have for the other part.